Hello students, welcome to one more exciting session of physical chemistry. In the last lecture we have done the basics of oxidation and reduction, and I strongly believe that without backing up the theory with the numericals, theory will not go long. You will not get the maximum benefit of doing such hard work by doing only theory. So guys, remember one thing: when you're doing theory, make sure that you are doing practice of questions on them, because in NEET entrance examination or any entrance examination you are giving, you are interested in, they will be asking you only numericals. They will not ask you theory kind of thing. They'll ask you only numericals, the questions basically. So please do practice questions. So today we'll be doing the practice of questions. Okay, so before we launch on to the question, one very important compound was left in the last lecture, so we'll try to complete it today itself, and the name of the compound is H2O2, right? So this is all about H2O2. So let's begin that and understand. H2O2 is the compound which can act as an oxidizing agent as well as a reducing agent. So before telling you what is the role of H2O2 in physical chemistry, let's revise once again in a nutshell that what we have done in the last lecture. So what is oxidation? Oxidation is basically the loss of electrons. And what is reduction? Gain of electrons. So if you lose the electrons, your oxidation state will go up. But if you gain the electrons, your oxidation state will go down. That we have learned. Acha, one more thing. If you are losing electrons, that means you are giving electron to someone else. And when you give the electron to someone else, you are going to reduce the oxidation state of the other element. So you will be actually acting as a reducing agent. Are you getting it or not? And if you are accepting electron from someone, that means you are going to increase the oxidation state of the other element. So you will be acting as an oxidizing agent because you have just oxidized the oxidation state of other element. An agent which can oxidize others is called oxidizing agent. An agent which can reduce others will be called reducing agent. Getting it? And who will be called reducing agent? Someone who donates electron. So you donate electron, you are reducing others, but you are getting oxidized yourself. And if you are accepting electrons, you are going down, you are getting reduced yourself, but you are oxidizing others. You are a reducing oxidizing agent. Okay? Chalo. So H2O2 is a very interesting compound, and the beauty of this compound is that it can go for, like say, in acidic medium and in basic medium. It can go for oxidation as well as reduction. It's very important. It can go for oxidation as well as reduction. So let's see one by one. Let's say first we'll see the reduction in acidic medium. So in acidic medium, H2O2, these equations are supposed to be learned, initially, okay? H2O2 will accept the 2 electrons in acidic medium. So when you say acidic medium, it has to be H plus, okay? And this will give you 2H2O. 2H2O. Can you see that? This equation is balanced? Yes, it is balanced. 4 hydrogen, 2 and 2, 4 hydrogen balanced. Oxygen 2, and charge also balanced. 2 plus and 2 negative. Overall neutral on the left hand side. It is neutral again on the right hand side also. Okay, now second one, oxidation. Oxidation of H2O2 in acidic medium. H2O2, students, will lose electrons to give you O2 and 2 H ions and 2 electrons. You can see that equation is balanced in terms of charge. Neutral here also, 2 plus, 2 negative, neutral, okay? And it is giving O2, and it is also in the acidic medium. Presence of H ions marks the presence of, like say, acidic medium, okay? Okay, so this is the reaction, or these are the reactions of H2O2 in acidic medium while it is reducing as well as oxidizing. But remember that in this reaction, when it is accepting electron, this is acting as the oxidizing agent. And in this reaction, where it is donating the electrons, in the second reaction, it is donating electrons, it will be acting as a reducing agent. Anything which can donate electron will be called a reducing agent. Anything which can accept electron will be called oxidizing agent. Okay? Now come over here. In the basic medium. So in the basic medium, we need the presence of what? OH negative. So let's bring that into picture. The first one again, the reduction over here. So H2O2 will accept 2 electrons to give you what? 2 OH ion. But you have to remember these reactions. Remember them. They will be quite beneficial in the later part of our journey. Okay. So this is charge balance 2 negative, and presence of OH negative shows that it is a basic medium. And yes, it is accepting electron. So it is acting as the oxidizing agent. Yes or no? In the basic medium. Second one, oxidation of H2O2 in the basic medium, and H2O2 to get oxidized, it should lose electrons. And yes, we need presence of OH negative also. So this will give you 2H2O2 or say 2H2O. So see that how many O? 4 O. We need one more O2, and yes, 2 electrons. So 2 electrons are being transferred in presence of basic medium, and charge is balanced 2 negative. Hydrogen how many? 2 and 2, 4. Here also 4. Oxygen how many? 4. Here also 2 and 2, 4. So equation is balanced, but over here you can see that H2O2 is releasing the electrons, so it will be acting as a reducing agent. All these reactions are extremely important. I'll heavily recommend, please do these reactions, and if you have done previously something of valency factor, you can check that valency factor of H2O2 in all these reaction is what? It is basically 2. So please make sure that valency factor of H2O2 in all the reactions is what? 2, whether acting as an oxidizing agent or acting as a reducing agent. So can I ask you a question now? H2O2 can act as an oxidizing agent or a reducing agent, or both, or none. It can act as an oxidizing agent as well as a reducing agent, both in the acidic medium as well as in the basic medium. Are you getting that? And you have to learn these reactions. Please do learn these reactions, and we'll be using them in the next lecture when we'll be doing the balancing of redox reactions. They will come to use. Chalo, let's move ahead. Okay, so now let us do one thing. We have done something about oxidation state yesterday, and we have known the minimum oxidation state and the maximum oxidation state. Maximum oxidation state is given by the group number itself, and minimum oxidation state is given by group number -8. Yes or no? We have done it last time. And let me take an example. Today to clarify what I'm going to explain. So let's take sulfur. We all know sulfur belongs to group number 6, oxygen family, and its group number is what? 6. If its group number is 6, maximum oxidation state of sulfur will be +6, and minimum oxidation state of sulfur will be -2. 6 minus 8 minus 2, and it can exist in between the further intermediate oxidation state, like say for example +4, we can have +2, we can have 0 as well, and yes, -2. So these are the allowed oxidation states of sulfur. I have a question for you. Tell me one thing. Is it possible for the sulfur to breach the rule of oxidation state? I believe that these elements are not like human beings. Human beings have a tendency to break the rules, traffic rules, civil rules, criminal rules, all that. But elements, they adhere to the rules in general. So sulfur cannot breach the maximum benchmark of +6. That means it cannot attain the oxidation state of +7 or say +8 or +9, whatever. These oxidation states are not allowed. That means what? If it was able to achieve these oxidation state, it could have done only by what? Losing electrons. If it will lose 1 electron, it will become +7. Lose 2 electrons becomes +8. That means loss of electron is not allowed. If it is not losing electron, that means it cannot act as a reducing agent. All it can do is that it can gain the electrons and come back to +4, can come back to +2, can come back to 0, or can come back to -2. Sulfur can play the game in this line, or say between this line. Now, if it is going to gain electrons, it is certainly going to act as what? Oxidizing agent. Yes or no? It will itself get reduced but will oxidize others. That means if an element is in highest possible oxidation state, it can act only as an oxidizing agent, but not as a reducing agent. Yes or no? Is that clear or not? Now let us look at the far end of the spectrum over here, where it is like, say, minimum oxidation state is what? -2. Okay, now is it possible for sulfur to breach this benchmark of minimum? Can it go to -3? Is it possible? Can it go to -4? Is it possible? No, it is not possible. Certainly not possible. Okay, that means, if it was allowed to go here, it would have gone here by accepting electron. That means gain of electron in this minimum oxidation state is not allowed. This is not allowed. If it is gaining electron, if it was gaining electron, it would have acted as what? Oxidizing agent. Yes or no? That means since it can't gain electron, it can't act as oxidizing agent also. Yes or no? What it can do? Again, the allowed pitch is this only, -2 to +6. It can move between -2 to +6. So all it can do is that it can move from say -2 to 0, +2, +4, or say +6. Now going from -2 to 0, +2, +4 and +6 requires what? It should lose electrons. If sulfur in -2 loses 2 electrons, will become what? 0. Loses 4 electrons, will become what? +2. So it can lose electron. If it is losing electron, definitely it is allowed. If it is allowed, it is acting as what? A reducing agent. A reducing agent is the agent which throws the electrons to other element. That means, now it is very clear, any element which is in the minimum oxidation state can act only as a reducing agent, and if it is in the highest possible oxidation state, it can act only as a oxidizing agent. Now, what about the intermediate states? So let's make it clear on the different page. -2, 0, +2, +4 and +6. So this is the play field. Right? Okay, now see that stuff. So what this +4 can do? +4 can lose 2 electrons, and can become what? +6. Can gain 2 electrons, can become what? +2. Can gain 4 electrons and will become what? 0. It can also gain 6 electrons and will become what? -2. Same thing happens with what? 0. 0 can gain 2 electrons and will become what? -2. It can lose 2 electrons and will become what? +2. It can also lose, say, 4 electrons. Lose 4 electrons will become +4, and so on. That means intermediate oxidation states can lose electrons, they can gain electrons. If they can gain electrons and lose electrons, they can act as what? Both oxidizing and reducing agent. Yes or no? So when say for this 0, it is gaining electron, it is acting as this part will act as what? Oxidizing agent. It is gaining electrons, and here it is losing electron. In these transition, it will be called reducing agent. So one thing is now clear basically. What is that? That maximum oxidation state. If element is in the maximum oxidation state, it can only act as an oxidizing agent. Yes or no? That means it can only gain electrons and be reduced. Yes or no? If the element is in the minimum oxidation state, it will be acting as a reducing agent only, oxidizing agent only, reducing agent only. Yes or no? That means what? If it is in the minimum oxidation state, it can lose electrons, can only lose electrons. Yes or no? And can be oxidized, So that is very clear. That is very clear to all of us. Okay? Now, intermediate oxidation states, they can lose electrons and they can gain electrons. If they are losing electrons, they are acting as what? Reducing agent. If they are gaining electrons, they will be acting as the oxidizing agent. That means intermediate oxidation states can act both as a reducing agent as well as oxidizing agent. Is that clear completely now? So let's practice some questions. Come on, let's do some questions. Chalo. Question says that which will act as only oxidizing agent or only reducing agent or both. Let's check it out. Let's check it out. Come on. So the first option I'm giving you is say H2SO4. Second option I'm giving you H3PO4. Okay. Third option I'll write it over here. Third option I'm giving you is say HNO3, or fourth option I'm giving you HNO2. Okay, we'll do more questions, but let us find it out. How about these things? Can you see that sulfur, if you have done the practice, sulfur exists in +6, we have done yesterday, and sulfur is in +6 means is in the highest possible oxidation state. And if anything is in highest possible oxidation state, it can act only as a oxidizing agent. It can only gain electrons. It can be reduced only. It can go to +4, +2, 0 by gaining electron. If you can gain electron, you are acting as a oxidizing agent. H3PO4, if you see that, +3X and oxygen -8. Each oxygen -2 in general, there are 4. -8 equal to what? 0. So X equal to what? +5. If you remember that phosphorus belongs to nitrogen group, and maximum possible oxidation state of phosphorus will be +5. Maximum. This is maximum and this is also maximum. If they are in the maximum oxidation state, they will be acting as an oxidizing agent. Yes or no? Only as oxidizing agent. HNO3 will be in +5. Yes or no? And it is also in group number 5. It is the highest possible oxidation state. That means it will also be acting only as a oxidizing agent. HNO2, come on, check it out. +1 plus X -4 equal to 0. So X equal to what? +3. Now we all know that nitrogen belongs to fifth group. Fifth group. That means minimum oxidation state will be what? -3, and maximum will be what? +5. Yes or no? Maximum is group number, minimum is what? Group number -8. So 5 -8 will be -3. So it can act, it can exist between -3 and +5. That it can be like say -2, -1, 0, +1, +2, +3, +4 as well. So these are the oxidation state which are allowed for nitrogen. Yes or no? But here it is in the maximum, so it can go only to lower one by gaining electrons. Yes or no? So it will be acting as oxidizing, this is HNO2. HNO2 is what? +3. So +3 is what? Intermediate oxidation state. It can go to +4, +5, +2, +1 and everywhere. So it will be acting as a both oxidizing agent and reducing agent as well. So let's do some more questions. Come on, let's see that what we can do of that. So one more example, we have got H2O2. Second example let us do will be like say NO, or we can have third example maybe say NH3. Okay, chalo batao. So H2O2, bachcho, H2O2 structure I told you yesterday is what? This one. So +1, -1, +1, -1. Yes or no? And 0, 0 for this one. So overall -1. In peroxide, I told you oxygen is -1 and H2O2. But you remember that oxygen in general can be between -2, -1 and 0. When it is like say acting as O2 in the free state, its oxidation rate is what? 0. Yes or no? In peroxide, it is like say -1, and in oxide, it is -2. Remember that? And in superoxide, it is what? -1/2. Remember that? We have done it yesterday in the superoxides. So right now oxygen is where? In the -1. In the -1, it can go here as well as there also. So H2O2 can act both as the oxidizing agent and reducing agent. This we have done In the beginning of the lecture, I told you that H2O2 can act as oxidizing agent as well as a reducing agent in acidic as well as basic medium. Is that clear? Chalo, theek hai. Now come to NO. NO, let's see NO. So NO will contain, this is say X minus 2 equal to 0, X equal to plus 2, and plus 2 is the intermediate state between minus 3 and plus 5. Over here it is say plus 2. So it is the intermediate state. It can go to minus 3, minus 2, minus 1 and plus 5, plus 3, plus 4 also. So it will be acting as a what? Oxidizing agent as well as reducing agent. I hope that is clear to all of you. Okay. So let's do some more practice of questions. Acha, I want to tell you one thing, that when I'm saying that H2O2, so X is equal to say minus 1. Oxidation state of oxygen is minus 1. And if it decomposes, it will give you 2H2O plus O2. 2H2O plus O2. So here it is water, it will be minus 2 oxygen, and here it will be 0. Whenever an element goes from, like say, minus 1 to minus 2, this is called reduction, and from minus 1 to 0, it will be called oxidation. Yes or no? If in an element, in compound, same element goes for reduction as well as oxidation, this kind of reaction is called disproportionation reaction. Disproportionation reaction. Are you getting that? So what I said just now, if in a compound, single element, same element goes for oxidation as well as reduction, this kind of reaction is called disproportionation reaction. So be very careful about it. Be very careful. So let me ask you a few questions, that which of the following reactions belong to the category of disproportionation reaction? Let's see that stuff. So tell me the first one, ClO3 minus going to give you ClO4 minus and Cl minus. Do you think that this reaction belongs to the category of disproportionation reaction? Let's check it out. So here X minus 6 equal to minus 1. So X equal to plus 5. So chlorine is in plus 5 oxidation state. Out here it will be X minus 8 equal to minus 1. X will be equal to what? Plus 7. Okay. And out here it will be X equal to minus 1 itself. So plus 5 is going to plus 7 will be called oxidation. Plus 5 going to minus 1 is called reduction. So same element, chlorine, is going for oxidation as well as reduction. This reaction is in the category of disproportionation reaction. No doubt about it. Okay. Let's see one more thing. Let's see Cl2 going to Cl negative and ClO3 negative. Can you do it quickly? Chalo. So here X is equal to 0. It is in the free state. Okay. And X equal to minus 1. Okay. And X minus 6 equal to minus 1. X equal to plus 5. Yes or no? So 0 going to minus 1 is called reduction. 0 going to plus 5 will be called oxidation. Same element going for reduction as well as oxidation. Yes, definitely this also lies in the category of disproportionation reaction. Acha, one more thing. If you reverse it, if you reverse the reaction, that same element going from reduction as well as say oxidation to find or to form a single element or single compound, this is called comproportionation reaction. What is this called? Reverse. Remember that, reverse of disproportionation. Disproportionation reaction is called comproportionation reaction. Comproportionation, very important. Comproportionation reaction. That means what? That same element in two different compounds, is going into a single oxidation state will be called comproportionation reaction. While what is disproportionation? An element in a single oxidation state is going into two different oxidation state, one higher, other one lower. Okay. So let's see that. Tell you one thing. MnO4 negative going to MnO4 2 minus and MnO2. Is it the case of disproportionation reaction? Is it a case of disproportionation reaction? Come on. So let's say x minus 8 equal to minus 1, x equal to plus 7. Yes or no? Okay, hey, come here. X minus 8 equal to minus 2. X equal to plus 6. Okay. And over here, x minus 4 equal to 0. X equal to plus 4. So plus 7 to plus 6 is reduction. Plus 7 to plus 4 is also reduction. So in both of them, both these compound, Mn is getting reduced. This is not disproportionation reaction. This is not. To exist as a disproportionation reaction, from here, one should go to reduction, other one should go for oxidation. Here, both of them are going for reduction. This will not qualify for what? Disproportionation reaction. Okay? Okay, come on. Let's do some more questions like which of the following is a redox reaction? Chalo. Which of the following is a redox reaction? Now, to exist as a redox reaction, understand the one of the element, at least one of the element should change the oxidation state. If no element is going to change the oxidation state, it will not be called redox reaction. Let's check. First one, say NaCl plus AgNO3 going to give you NaNO3 and AgCl. Do you think this is a kind of a redox reaction? Let's check it out. So this is what Na plus, Cl minus, Ag plus, nitrate, Na plus, nitrate, Ag plus, Cl minus. So Cl minus stays Cl minus, no change. Na plus exists as Na plus, no change. Ag plus also exists as Ag plus, no change. And nitrate also exists as nitrate. So there is no really change of oxidation state. So this reaction is not a redox reaction. This is not a redox reaction. Come on, second one, HCl plus NaOH will give you NaCl and H2O. Come on, is this a case of redox? Let's check it out. H plus Cl minus, Na plus OH minus, Na plus Cl minus, and this H2O is nothing but H plus and OH minus kind of thing. Yes or no? H plus is H plus, no change whatsoever. Cl negative, Cl negative. Na plus, Na plus. OH negative, we have got OH negative. That means oxygen is in -2 and H is in +1 always. Because if you look at this thing, O, H and H, +1, -1, +1, -1. Total becomes -2. Yes or no? Oxygen will be -2 here also. How come? Na plus, O negative, H negative, sorry, plus and negative. So total become what? -1, -2. And here also -2. There is no change in oxidation state. Chalo, come. One more. Let's do that. Third one. Let's have, say, H2S plus H2O2. It is going to give you sulfur plus 2H2O. Come on. Sulfur is over here -2 and here it is 0. Clearly there is a change in oxidation state. Definitely this will be called a redox reaction. Also oxygen is in -1 over here and here it is say -2. So there is a change in oxidation state. This will be called redox reaction. -2 to 0 is called oxidation. -1 to -2 is called reduction. So it is a redox reaction. Yes or no? So I hope that we have done a decent amount of questions, and I hope that this is going to help you a lot in your practice sessions as well. So please do keep practicing these questions, and you can solve your modules or any book and let me know that what kind of problems you are having, and we'll meet next time in the next lecture. It is a very important lecture waiting for you people. We'll be doing balancing of redox reaction. So come prepared with all these things because they will be utilized in balancing of redox reaction. Please keep revising, keep practicing. God bless you all. Bye-bye. Bye all of you.